All right, let's talk about the possible rational zeros, also known as the PRZs. And when we have a function like this, okay, in this case it has a degree of 3, it's not going to be very easy to factor something like this. So if we want to find the zeros, what we're going to do is first we're going to list all of the possible rational zeros. And we can do that using a thing called the rational zero theorem. And what it's going to say is that as long as you have integer coefficients, okay, no fractions, all of your factors of this term here, 175, we're going to call those our p's, and then we're going to divide those by all the factors of our leading coefficient, which we're going to call the q's. That's going to give us our possible rational zeros. Okay, so what we're looking for is we're looking for our p's over our q's. Okay, and I'm going to put a plus and minus because we're going to take the positive and the negative versions of these. So let's go ahead and list all of our q's first. Let's do the q's. So here I have a number 3, and the only factors of 3 are going to be 1 and 3. All right, now let me put 175. Oh boy. The factors of 175. Well, I'm gonna do my factor pairs. Okay, I'm gonna start with number 1. 1 times 175 will give you 175. Okay, and then 2. Does 2 go into 175? No, it's an odd number, but you might want to grab a calculator so you can follow along. 175 divided by 2. No, that doesn't work. 175 divided by 3. No, that doesn't work. 175 divided by 4. No. 175 divided by 5. Yes. So 5 times 35. That's 2 more factors. They both go into 175. And then you're going to keep going down the line. You're going to try 6. 175 divided by 6 does not work. 175 divided by 7. Yes. 7 and 25. Okay, and you're going to keep going down the line. You're going to try 8. You're going to try 9. You're going to try 10. 11. 175 divided by 12 doesn't work. 175 divided by 13 doesn't work. 175 divided by 14 doesn't work. 175 divided by 15 doesn't work. And what I've noticed is actually when I get to 14, the number that I'm trying to divide by, 14, gives me back a number that's smaller, 12.5. And at that point is where I stop, because no other numbers are going to work until I get back up to 25. So these are all of my factors of 175. And now we just have to list them all. Okay, so get ready. It's going to take some space. I'm going to make a fraction bar here. And I'm going to put all the possible factors of 175, starting with 1, 5, 7, 25, 35, and 175. And I'm going to put them over all of my q's, plus or minus 1 and plus or minus 3. All right, so I'm going to list them out now, noting that if you get a repeat, you don't need to write it twice. So if you get 3 and then you see 3 again later on, you don't need to write it twice. So here we go. 1 over 1 is 1. 5 over 1 is 5. 7 over 1 is 7. Right? 25 over 1 is 25. So we can just write all of those. Let's put plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 25, plus or minus 35, plus or minus 175. And then we're going to put 1 over, I'll do a different color, 1 over 3, that's 1/3. So I don't have quite enough room over here, plus or minus 1/3. 5 over 3 is 5/3, plus or minus 5/3. You know what? I do want to put them on the same line. Let me move this. Let me do a little internet magic here. Just move it right there. There we go. 5 over 3, and then we're going to continue. 7 over 3, 25 over 3, 35 over 3, and 175 over 3. All right, we will reduce these fractions if we can. For this problem, none of them reduce. 25 over 3, 35 over 3, and 175 over 3. And these are all of my possible rational zeros. So if I wanted to find zeros of this polynomial here, I would probably just start with number 1. And then I'd try number 1, then I'd try negative 1. And then I'd probably go to 5 and negative 5, and then 7 and negative 7. I would not start with the fractions first because that sounds a little more complex than I need to make it. All right, so that's it. Possible rational zeros, PRZ.